Zsolt is already joining, doesn't want to miss a thing. That's the spirit, Zsolt.
Cannot see who is connecting because
He put a question in the Q&A. You can see those, right?
No, because in this full screen mode, I don't know how to go out. When I'm sharing the screen, I
it's just
went into the full screen mode, so I'll see later.
Okay, so I switched the Q&A box so that people can see the questions. Also, the attendees can see the questions. Christina, there is a question in the chat that the wiki link is not working for the participants. Did you already add the slides to the wiki, or is it still is the link still empty?
Yeah, the link is empty.
Okay.
Do you want me to do it now?
Well, if you have a Drive or a Dropbox link, I can add it for you. If it's a file, then we'll have to wait until afterwards.
Okay, let's do it afterwards.
Okay.
If they really need it now, we could do it now, but
yeah, we only have about a minute to go, so let's not stress out ourselves. Good afternoon, everybody. We're at 1:30, and people are still trickling in, so let's give 1 or 2 minutes for everybody to get settled, and then we'll start. Okay, welcome everyone. This is the last lecture of the CASA-VLBI workshop, which we've been running this week. Welcome also to some of the other people that I invited from Astrometry JIVE who are here to join for the lecture. I'm really glad you could make it. So the last lecture will be given by Cristina Garcia Miro. She is working for JIVE and has spent a significant amount of time of her job also at the SKA office, where she's been involved in studying the opportunities for the connection of VLBI and the SKA. And she's going to talk to us about the future of VLBI. Thank you, Cristina, for being here, and you can start.
Thank you, Ilse, for inviting me thank you to the organizers for inviting me to give this closing lecture. It's a pleasure for me. So it's been like a third of the fourth time that I've been invited to give a lecture on the future of something. I'm a bit suspicious, you know. I'm starting to think, what are the really skills that they are looking on me? Okay, so I like starting just with a bit of a joke. So let's talk about the future of VLBI. And I want to divide the talk in 4 parts. So first, you've been learning this week what to do with VLBI. So let's review that. So what we can get from VLBI right now and where we are heading to, what we will be able to achieve in the near future. And the third part of my talk would be what would be the future of the VLBI in the SKA era, and all the science that the SKA VLBI capability will allow to end. So this is the first image of a radio source that was ever produced. This is Cygnus A, if you remember, it's very famous. And it's quite good, actually. It was produced by Jenison and Dasgupta in the 53 with one of the first connected interferometers. But from this image to this state-of-the-art image of the event horizon of the supermassive black hole in M87, so actually 50 years have passed, you know, of improving and advancing the calibration and the processing techniques. So what we are getting from VLBI right now, so we are talking the stream angular resolutions that we can achieve with radioastron, for instance, or EHT are about 10 to 30 microseconds. Dynamic ranges normally are 100 to 1. Spatial dynamic range is 1000 to 1. Dynamic range is the most brightest thing compared to the most faintest thing that you can get in a map, and a spatial dynamic range is the smallest to the largest thing that you can resolve or detect. So that's what I'm talking about. So if we include Merlin baselines in the EVN, we are reaching right now 1,000 to 1 spatial dynamic ranges. Positional accuracies with absolute astrometry, we are achieving 100 microseconds. With relative astrometry, when we are studying individual sources, that goes down to 50 microseconds. And field of views, historically, VLBI has been just limited to few seconds, but now with the new techniques, we are able to image the full beam, reaching tens of arc-minutes. So plenty of signs have been addressed already in these 50 years, okay? This is just a sample, so everything about just jet physics. We know lots about relativistic jets nowadays, and transients like the latest gravitational wave events and the counterparts where the FRBs localizing them, and very detailed dynamic in the galaxy and in the clusters and reference frames, celestial reference frames. But do we need more? And I'm hearing like more. Of course we need more. So it's just been published a great document that establishes the scientific roadmap for the next decade for the EVN network, and also for VLBI. And this is a Jumping JIVE project, a European Union funded project, deliverable, and it establishes the role of the EVN, VLBI in the future astronomy landscape. It is about 200 pages of science, divided in 7 chapters. 80 authors have contributed, and it gives us the 8 key science goals that VLBI would be able to contribute in the next decade. So, and these are the other facilities would like to answer these questions as well. But yeah, VLBI would be able to contribute. So what is the nature of dark matter, dark energy? How the first black holes were formed? How these relativistic jets form, and how do they impact their host galaxies? What is the physics of the gravitational wave events? What are these fast radio bursts? And the 1 billion question, are we alone? How was the Milky Way born? And how do the stars are formed, and how do they enrich the environment during their lifetimes? And the document also contains all the technical priorities that would be needed to achieve all these goals in the next decade, and synergies with other facilities, radio astronomy facilities, multi-wavelength, multi-messenger facilities. So, but how do we achieve these goals? How we to get more? So I'm going to talk about these 5 topics. Ultra-precise relative astrometry, extreme angular resolutions that could achieve with the space VLBI, continue with the wide field imaging that we've been learning during this workshop. Imaging, let's not forget, is going to be very important, the low frequencies, imaging at very low frequencies, and imaging with, of course, this more I was hearing in the background, with higher fidelity, higher sensitivity. So ultra-precise astrometry. So VLBI is the technique that provides the highest accuracy and precision for the determination of positions, distances, motions. And the goal is to reach these ultra-precise astrometries to 10 times better than we are doing right now, so achieve micro-second resolutions. But not for individual sources, for large and complete surveys. So we will be able to achieve this with the next generation instruments like the SKA and NGVLA. So astrometry calibration needs special techniques to preserve the astrometry information. Self-calc destroys, get rid of that actually. So we need to use different approaches to reach what we call the thermal limit, the interferometer thermal limit of the interferometer. That so this the error in the position is proportional to the size size of the resolution of our beam, the resolution of the interferometer, divided by the signal to noise of the observation. So, and as we've learned also during the workshop, these relative astrometry techniques are very important for imaging faint and or extended targets. So I just want to review very fast because we haven't talked about this in the workshop, but yeah, maybe you've heard about it. What are the phase calibration techniques? So these three are the standard ones that has been using for decades. So the conventional phase referencing is observing your target and observing a reference source, a calibrator, and switching very fast between both of them to correct for this for the phases, for the distortion of the phases that the atmosphere is introducing and other effects. If you are happy and you have a dual beam system, you can observe simultaneously your reference and your target. That's what beta does, the beta interferometer. In lower frequencies, that your beams are wider, the antenna primary beams are wider, and also the sky is more populated, you are lucky enough to be able to have your target and your reference source in the beam, and that's what is called in-beam phase referencing. So when you use these like observing modes together with advanced astrometric calibration methods, like inserting in your schedule geo blocks to correct for troposphere effects, or ice blocks for the ionosphere, you get precise relative astrometry. So what is the next generation of astrometric calibration techniques? So we have, for instance, short frequency phase referencing that is observing in fast agility mode, in frequency agility mode, different frequencies, and is transferring the phase solutions from the lowest frequency to the highest. So that's allowing to do astrometry, relative astrometry at millimeter wavelengths, and reach coherent times, the order that was impossible before, the order of hours at 130 gigahertz. That's outstanding. So these observations can be done simultaneously at the KVN network that we have the quadruple receiver. You need to observe also, in this case, a reference source and switch between your target and the reference to correct for the ionosphere. But also you could just, in the multi-frequency phase referencing, use just the source, your target, and include in your schedule ice blocks to correct for the ionosphere. And one of the latest techniques developed by Rio Dodson is the multi-view technique that, instead of using just one reference source, uses many around your target, at least 3, and cycles around them. And well, that is a method that could be used for both ranges, for low and high frequency ranges. And if you want to correct for planar effects, you just need 3. But if you want to go to higher curvatures to correct for a higher order, you need to observe more calibrators. So with these techniques, these just next generation techniques, we've been able to achieve up to 10 microseconds for the high and low frequency regimes, with a dynamic range of approximately 100 to 1. So with the next generation instruments, that is, the Rs improve by an order of magnitude, there are wider bandwidths, larger field of views. So the thermal limit would be reached with much better precision. So for higher, above 6 gigahertz, we will be able to reach 1 microsecond accuracy in positions, and enable precise astrometry for much lower frequencies. Okay, so as I said you before, VLBI is the technique that is providing the better angular resolutions in astronomy nowadays. So why not exploiting that till the limit? So there's been a study, a concept for a space-borne radiant interferometer presented by Gurbitz et al. To the ESA Voyage 2050 call. And it would exploit ultra-sharp angular resolution down to microarcseconds and sub-microarcseconds. So it's orders of magnitude better that in resolution and dynamic range that we are getting right now. So there will be a breakthrough in the studies with this high resolution. So we'll be able to image the event horizons of supermassive black holes that are farther away from M87, a bit smaller, maybe study the physics of where the jets, the relativistic jets, are being actually launched, going down to parsec scales, and study binary AGNs, time and X-ray domain synergies, mega masers in other galaxies, protoplanetary disk, exoplanets, and SETI, why not the techno signatures. So in the topic of wide field VLBI imaging, thanks to these advancing techniques, the VLBI has become a survey instrument. So before we were just focusing on single sources, but now we are able to do surveys. So the fields of view have improved to up to the tens of arc-minutes, and if you have fields that are larger, you use mosaic, as Jack Radcliffe was telling us yesterday with the VLBA Cosmos. So this has been thanks to the software correlators, to the advancing software correlators. We are not limited anymore in a spectral and temporal resolution. And so, and also these software correlations are allowing us to have many different phase centers, not just one. So this has allowed to map the whole primary beam of our antennas. And as Jack was telling us the other day as well, these two projects, VLA Cosmos and GOOD's North Field, are using this advanced calibration technique that is called the multi-source self-calibration, that allow us to, together with the primary beam corrections, allow us to reach the micro-Jansky regime in these surveys. This has direct application to multi-beam telescopes that I'm so much interested, and because we could point these beams to different phase centers to target the sources, target all these sources that have been detected. And also we will be able to do it with the large single dish antennas with the phased array feeds installed that enlarge their field of views. And also has a direct application on the determination of direction-dependent calibration. As Jack was telling us, this is a field that is being developed just as we speak. So, but apart from multi-source self-calibration, there are other techniques, there are other algorithms. So, for instance, when you have a very complex and extended structure in your field, so it is not so easy to map that field with just delta functions. So multi-scale cleaning has added also Gaussian functions that to improve these models. There are other algorithms like compressed sensing that produce very accurate models that could use for the EHD, for instance. And when you have large field of views, your plane of the sky is not plane and is not a plane anymore. It has a curvature, and your Earth has a curvature. So you cannot assume that you cannot play with planes anymore. So you need to correct for the W term, what is called the W term. So this algorithm W projection is taking care of that. Also how the PSF changes over the large field of view, the large image. Very important for projects like Cristiana Spingola was telling us the other day, that they have a very extended, complex and diffuse structure. So when you try to define your cleaning window, your mask is quite difficult. So there are algorithms that to help you do that automatically, automatic scale dependent masking. So that's been applied in Cristiana's project, SHARP program. Other algorithms to take into account the spectral variation, the multi-frequency deconvolution, or when you have a so large field of view, you need a special algorithms to do the gridding of the images and of the visibilities. And so that's done, for instance, with image domain gridding that takes care also of the direction-dependent effects. And I don't know, also parallel cleaning, so you can divide your field of views in small images and clean in parallel. So most of these routines have been included in the WSClean of Fringa package, and for instance has been used by Tom Muxlow in his eMERGE and et al. in their eMERGE library, and it uses the W stacking for the Merlin large field of view. Okay, imaging at very low frequencies. So historically, VLBI has been focused on centimeter wavelengths, but LOFAR has opened the range of lower frequencies. So, and in those frequencies, the direction-dependent effects are very important, the ones that are caused by the ionosphere. So they affect not only the position, it shifts the position of the sources, but also there's a defocusing in the brightness. So Rioja and Dobson have developed a calibration algorithm called LEAP for MWA that corrects for these two effects, the shifts and the focusing. It's a real-time phase calibration that is done in the visibility domain. It's done in real time because it doesn't need an SKA model, and it uses the frequency smearing as a very effective directional filter. It will be directly applicable to SKA1 low when they've been formed to create the tidal rate beams for pulsar timing, for observations of pulsars or for VLBI. So it will be very relevant for SKA1 low. If you use LEAP in conjunction with WSClean, you are able to get wide field of views with direction-dependent effects corrected. Okay, but there are other solutions for DDEs, like the one that is used in LOFAR facet calibration, and that divides the field in small facets where the direction-dependent effects are considered constant, or more modern, this model by Albert that uses a probabilistic model for inferring these ionospheric phase screens. So these calibration techniques have been used for the LOTS LOFAR survey. And here I wanted to show you the record for highest spatial resolution at 55 megahertz that has been achieved by Lee Moravito using standard VLBI calibration techniques. Okay, and to finish this second part, let's see how we could improve the fidelity and sensitivity of our maps, and that's completely related with the technical enhancements that we are going to that we will need in this next decade. So we will need broadband receivers that cover at least from C-band to X-band to improve sensitivity, instantaneous coverage, and also improve the efficiency in the observation, so we don't have to observe for so long. And it would require that these new receivers have a good polarization response. So for instance, brand EVM would be one of these receivers. We will need to increase the data rates. If we For instance, in DBN, we are using 2 gigabit per second right now, so increase by 4. So we will need solutions to handle data storage, connectivity, and do that correlation. And we would be interested on extending the frequency coverage to higher and lower frequencies and increase the number of antennas that are able to serve at these frequencies. Also, to improve the fidelity, we need to improve the UV coverage. So we need more antennas in the networks, especially towards the southern hemisphere for SKA synergies in the future. So, and I will tell you a little bit more on this on a second. Also, extend the field of view. So we want really, if we want to do surveys, so we want to have even wider field of views. So installing puffs in the larger antennas. In this way, we will be able to align the surveys that we will do with VLBI with the surveys that will be done in other astronomical facilities. And all of this would need an enhancement of the software correlators to cope with these upgrades, with more telescopes with multiple beams, with new serving modes, etc. So on the UV coverage, so this is a sample of the EVN, of course, and it's been a great achievement that we've been able to include the Merlin baselines in the EVN correlation. So that has improved tremendously the spatial dynamic range. So, but with many times the VLA sensitivity. So when you go to global VLBI and use a multi-frequency synthesis, basically you have coverage the whole UV plane. Okay, so there are efforts to establish a global VLBI alliance to promote, to have a truly global collaboration for VLBI in the world, and that, to promote that, and that alliance has started to improve the increase in the number of antennas that will participate in the network. So there I've added the potential collaborations that we may have in a near future we've already had. So as you can see, VLBI is really improving. And this is the example of the African VLBI network. And there's the idea to refurbish all these telecommunications antennas. One of them in Ghana, this one has already been refurbished and is being used as a radio telescope. So for the African VLBI network, we could follow this path, or there could be other solutions. So, well, there's a study by Sarao, we call the collocation program, that is studying how to support this development together with development of the local industry. So to collocate not only the science, to collocate industry together with the science sites. Okay, so as you can see, the UV coverage with the midterm AVN would improve a lot, and with the full AVN would be fantastic towards the southern hemisphere for future synergies with the SKA array. But meanwhile, when we do global VLBI with the long baseline array in Australia, EVN is Asian VLBI network, and AVN just Ghana, and if we could include Meerkat, so we get quite reasonable UV coverage at most of the declinations. Okay, and I just wanted to do a parenthesis here and talk a little bit about the sustainable development. Because all this development is very nice, but needs to be done in a sustainable way. And the United Nations in their General Assembly last month has recognized that and has set these 17 goals for sustainable development for the incoming years. And so first I was like, oh my goodness, so what I'm going to do, how I'm going to do VLBI sustainably. So do I have to take my bag? Okay, just joking. So the SKA and the precursors that have already the precursors develop and build the precursors on the future SKA sites are already taking into account these United Nations Sustainable Development Goals. For the African VLBI network, the data program that is development of Africa with radio astronomy is also based on these goals. And let's not forget that the VLBI is an international collaboration. It always has been. It cannot work without it. It's truly an international collaboration, and different cultures, diversity is just in our veins. Okay, so this is the third part of my talk that I'm going to talk about the future of VLBI in the SKA era. So why we would do VLBI with the SKA. So this is a plot by Jack Radcliffe that I like very much, that shows the angular resolution of the different connector, like VLA, a connector interferometer, but also in the different configurations, but also all the VLBI networks and global VLBI, and where are the different niches in angular resolution. So SKA is going to change dramatically this picture because it's going to cover all of the angular resolutions, okay? But till we get the full realization of the SKA2, so VLBI is going to provide, is still going to provide the highest angular resolutions to the high priority objectives of the SKA. So it's going to allow us to do already with SKA1 mid, well, in this example, SKA2 science. So yeah, so why, a little bit more on why we want to do VLBI with SKA. So as you know, the SKA is going to have, is one observatory that is going to have two telescopes, one in South Africa, that is going to be in the phase 1 about 200 antennas, in phase 2 3,000 something thousand of antennas, and SKA1 low in Australia, that is a different type of antennas sensitive to the lower frequencies and dipoles. So first phase is going to be like 130,000 antennas. The full phase is 4 times more, something like that. So why we want to, what SKA would provide to us? So it will provide independent and multi-beam capability from these 2 telescopes. It will boost our sensitivity to the micro-Jansky regime. It will allow us to access the southern skies on the galactic center for longer times. And it will allow us also not only to do VLBI, but to observe in other modes, in other of their observing modes simultaneously, and it will provide superior amplitude and polarization calibration. And these 2 telescopes are located in a pristine RF environment, and also the telescope will use state-of-the-art RFI detection and excision algorithms. So what we would provide them? So images on the sky, a broad range of angular resolutions, as I told you before, millisecond resolutions for high priority objectives, for the high priority science, independent commissioning tools. This is very important to help them to understand how their system works, and early public relation opportunities. And of course, and I think this is the best, is an enthusiastic and an expert user community. Okay, so realizing about this importance, the Jumping JIVE project that is funded by the European Union, the Work Package 10, is providing support for the SKA integration and operations within the VLBI networks. It's led by Sol Paragi at JIVE and Antonio Crisostomo in the SKA office, and I'm the SKA VLBI project scientist. I was working in the SKA office for 2 years, and now I'm working for JIVE till the end of the project in July. It has been extended. So how we do VLBI with the SKA? So the SKA will provide these multiple beams, typically from the core. So we will phase up the core to produce multiple beams, up to 4 or maybe even more. But also, we will be interested on using individual SKA antennas or stations to cover the short UV spacings, as exactly the same as the EVN is right now using within Merlin. The SKA would be able to define these different subarrays with different number of antennas and use them independently for different purposes. So for instance, for us, if we wanted to serve 2 frequencies like L band, band 2, that is going to be SKA, and band 5, that is C band. So we will be able to divide the core of the SKA in 2 and get 2 subarrays producing these multiple beams in these 2 different frequency bands. Within each subarray, we will be able to get all the observing modes simultaneously. So you get the imaging from SKA, continuous spectral line, and also imaging for slow transients, and non-imaging. So transient and pulsar search beams, pulsar timing beams, in case you're observing a pulsar and you want to measure very accurately the arrival of the position of the signal of the pulsar, and transient buffered for transients, and also VLBI beams. All these together for each subarray simultaneously. And also these beams within each subarray will be able to be controlled independently. So point different points in the sky, but also control them differently in scan boundaries. So the support to the SKA project, we foresee that it would be done by an SKA VLBI consortium, that it would be formed by the main VLBI networks and institutions, research institutions that are interested, and observatories that are also interested in observing with SKA. Okay, so more in detail how SKA is going to collaborate in VLBI observations with SKA1 MID. So they will be able to provide, as I told you, all these observing modes within each subarray simultaneously, but with a bandwidth sacrifice. We won't be able to get if we want to get different observing modes, we won't be able to get the full bandwidth. And here in gray, you have all the details I'm not going to go through, but this is for your reference of the different things that we can get with SKA1 MID. Maybe more interesting for you is that we will be able to have different sizes of the core. So depending on the field of use you want to reach in these VLBI beams, or the sensitivity that you need, you will have to reach an agreement. Okay, so lots of sensitivity, you get more antennas in your subarray, in your core, a larger diameter core, but also your beam is going to be very, very, very narrow. Okay, so you'll need to reach an agreement for that in your observations. So for proposal preparation, we will have templates to help to guide you with this. And on the right, you have the system equivalent flux density that you would expect with these different configurations, with these different diameters of the core. And on the bottom, the baseline sensitivity that you would get with a 1 minute integration, assuming a 100-meter class telescope on the other side. And this is just to show you that you will be able to get all these observing modes simultaneously in most of the bands, because the bandwidth is quite limited. So band 1, band 2 is just about 1 gigahertz bandwidth. So the processing resources are quite enough for that. But when you go to band 5, there are just sufficient processing resources to process full bandwidth with just one processing mode. Okay, so you are able to get VLBI beams 2 or 4 with 5 and 2.5 gigahertz bandwidth, but none of the other modes simultaneously. And if SKA is doing full imaging, full bandwidth imaging, there won't be resources for any other observing mode. Okay, with low, we won't have that limitation because the bandwidth is very small. It's just 100 megahertz, so all the observing modes will be able to be provided per subarray. So there's no problem at all with that. And also just check the gray window for the details. Okay, in this case, the array would be limited on the size of the core that will be able to phase up to 10 kilometers radius. That would be the maximum of the size of the core to phase. And there you can see on the top you have the system equivalent flux density for these configurations, and the baseline sensitivity you would achieve with, again, 1 minute integration and 100 meter class. I've assumed 100 meter class on the other side for low frequencies. Okay, so you will be able to achieve hundreds of microjanskis in 1 minute. For mid, it was tens of microjanskis in 1 minute. Okay, and now just a short note on how the SKA Observatory will work, because it can influence the VLBI way, the way that we do VLBI and we are used to do things. So the SKA Observatory is going to produce per year 300 petabytes per year per telescope, so a total of 600 petabytes. And an estimate of 250 petaflops. Okay, so the image cubes are the visibility sets are the order of 10 to 100 terabytes. So that's not possible to be able to provide to the users, to the scientists. So you will get the SKA science ready product. So the SKA image cubes already that anyway will have terabytes of size and 2 to the 16 frequency channels. So they will be also quite large, but you won't forget your visibility, so you won't get them anymore. So the way that SKA will work, it will have a tier model for regional centers. We will have this distributed network of regional centers that each will have like a subset of the SKA archive, and with processing and post-processing capabilities for the user to be able to access, and they will be responsible for distribution of the data to the users and to give user support. And the idea is that they follow the open science model. So to change the culture of radio astronomers on the data, on not having these visibilities anymore, that's why the SKA project has launched the SKA data challenges to change the culture on post-processing and analyzing of the radio astronomy data. And also is going to pose a change into the VLBI world as well. So just wanted to tell you a bit of these data challenges that the SKA is doing. So the data has different layers. So from the correlator, we get the raw data. SDP, as a science data processor, provides the products calibrated, and the SKA regional centers provide the advanced products that the key science projects use to produce the scientific results. So there are different stages where you can do the data challenges. And the first one would be at the SDP level, what is called the SDP de-risking big data challenges using 10 to 100 terabytes of data. But the SKA project has started with what they call the science data challenges with the data sets of the order of terabytes that are letting the scientists play with these science-ready products that the SKA will produce. And they've already started with, they've done already one data challenge, that it was a continuum image that had 10 million sources, 32K by 32K pixels, 4 gigabyte size. It was 3 frequencies, 3 depths, 8 hours, 100 hours, 1000 hours. And the goal was to find efficient methods for source finding and characterization and classification. So this was very successful exercise. 9 groups participated, and Anna Bonaldi has recently published the results. And they've just launched the second data challenge. That if you are interested, you are still on time to express your interest, and it's a neutral hydrogen image product that is the order of a terabyte, 20 degrees square in size, covering that redshift, and it will contain, this is a bit of a spoiler, I shouldn't tell you, because maybe you want to participate into the 6 H1 galaxies and to the 7 continuum sources. So about 30 teams have already expressed their interest. And of course, for analyzing that, they will need resources, HPC, high processing computing resources. So some agreements have been already in place for them to be able to use several different facilities. So if you are interested, go to the SKA webpage to register your interest. Okay, for VLBI, we are also interested on doing data challenges. So there are like 2 different paths for the data. So SKA will produce visibilities from the VLBI observations, and from these visibilities, the SDP will produce images, and the SKA regional centers will provide us with advanced imaging products. We are foreseeing this for calibration, for instance, because if we observe a calibrator, it won't be resolved out in the SKA images, so it could help tremendously in the data reduction for VLBI. So the other data path is they will also provide the SKA VLBI beams that, together with the other VLBI stations, will be sent to the VLBI correlator to correlate all these together. And these raw visibilities, well, they will provide it to the scientists, to the key science teams, and that will provide that they will produce a product and analyze it and publish results. So the SKA advanced imaging products will help to reduce post-process these raw visibilities. So we are thinking on exercising data challenge on this stage, what is called 1, and on the second stage, number 2. Okay, and now to finish with my talk, this is the last part that I want to tell you. So including SKA in the VLBI networks, in the VLBI observations, what science I would be able to do. So all this was discussed in last year, sadly a year ago, in the SKA headquarters in Jodrell Bank, where around 70 scientists gathered together to discuss what is the key science themes that we'll be able to solve with this capability. This workshop was supported by Jumping Jive, by the SKA and RadioNet, And also I wanted to mention you that the SKA has the SKA VLBI Science Working Group that you could, if you are interested, you could join the efforts. And the chairs right now are Tao An and Cormac Reynolds, and previously was Sol Paraji. So during the workshop, we divided in 4 working groups, divided in different science topics, AGNs, star astrometry, transients, and pulsars, and these groups were led by these colleagues. And they've established, each group established their key science themes for each of these topics. So for the galaxies and AGNs group, determined that the key science themes are going to be the separation between AGN and star formation, supermassive black hole evolution, the feedback and fueling of the AGNs in the host galaxies, or the physics of the relativistic jets, studies of dark matter with gravitational lenses, and black holes and cosmology. In this topic, it was highlighted the importance that SKA low VLBI would have with the high resolution sensitivity and the low frequencies, because the low frequencies for AGN's studies are a unique proof of the science. So it helps to disentangle between the AGN and star formation activity. It helps characterize the FR1s versus FR2 populations. For radio loud AGN, you can do all the physics of the hotspots with the spectral modeling. For radio quiet, very interesting to know the origin from where the radio emission comes and identify the core, where's the core, if there's a core, and study these small scale jets or winds and any gravitational lens effect that you may have. And the goal would be to build a sample of resolved high redshift AGN, of course, in these frequencies. For centimeter frequencies and higher frequencies, that will be covered by SKA1 mid and with VLBI. So you also get advantage of this high resolution sensitivity and the multiple beams. So we are interested in knowing how is the sky at these frequencies with below or better than Microjansky's sensitivities. And building on the deep field surveys that the SKA is going to do, target on a specific target the beams on a specific sources. Well, it would provide plenty of science to exploit, like feedback of supermassive black holes on their host galaxy, also trace the emission for this AGN again, and star formation activity. As you know, VLBI is one of the best techniques to detect AGNs, and also it would be very useful for supermassive black holes binaries, gravitational lenses, radio supernovae, and low luminosity AGNs, etc. Okay, the second group, that it was stars and astrometry, identified these key science themes. So young stellar objects, stellar evolution in general, from young stars, as you see, to evolved stars, dynamic of the clusters and local galaxies, global astrometry, explosion, novas, flares, exoplanets, stellar jets, etc. So in this theme, in this topic, SKA VLBI would be the most powerful tool for astrometry. And with this, the new phase calibration techniques that I've told you before, for instance, multi-view, we will be able to reach this 1 microsecond resolution for higher than 6 gigahertz. So with this ultimate astrometric accuracy and then dramatic increase of number of targets due to the increase of sensitivity, so we will be able to build this large and complete surveys that would enable new discoveries. So just to mention, determine the orbits of the exoplanets, parallaxes, geometry parallaxes up to 100 kiloparsec, pulsar parallaxes in the galactic center, methanol masers, detect methanol masers in the large Magellan Cloud, and study the launchings of the relativistic jets. Okay, and to finish, the last two groups joined together to define the key science themes, and they've determined that, of course, it's going to be the counterparts of the gravitational wave events, studies of FRBs, fast radio bursts, exoplanets, try to detect more magnetars, studying pulsars, gravitational gamma ray bursts, novae and supernovae, and tidal disruption events, and more.
Christina?
Yes?
5 minutes.
Good. Okay, just 2 or 3 slides. So SKA VLBI in this theme, in this topic, will be able to measure very accurately the source's expansion, the apparent jet speed, proper motions, distances through the parallaxes. So with that, we will study the faint synchrotron radio transient local universe. So we will be able to resolve the ejecta within weeks and measure proper motions in the microarc regime. For gravitational wave astronomy, we will resolve the relativistic outflows, FRBs, localizations, and study of the progenitor environments, so planets, again, to measure the orbital motions. Magnetars reach the galactic center and cover a larger galactic volume for searchers. Okay. Okay, so as you can see, the VLBI future is bright and is sustainable. But mostly the VLBI future will be built thanks to you. And that's the end of my talk. I apologize if you cannot find your name in the slide. I did my best to try to recover all of them, but well, I couldn't. I know there are many names that are missing, but it's just wanted to show that that you are the key part of this game. Okay, also our sponsors, thank you to them, and mostly thank you to you, and thank you to the organizers for this splendid workshop and for the work that they've put on it. And if you are interested on this SKA VLBI effort, please drop me a line to that to my email. Okay, thank you very much.
Thank you very much, Christina. I really do like your crystal ball image that we'll no doubt steal at some point. So we've already got a few questions popping in, and people have the opportunity to upvote questions or like questions if they've got a similar one. So we'll start from the top, which is a somewhat technical question. Ajit Sampath is asking, in the multi-view technique, which we can use for low frequencies, why should the T-cycle be 5 minutes? What if we are observing with a dipole array where pointing the beam is stepwise and locating a calibrator, observing it and getting back to the target takes much time? How can we do astrometry with that without using self-cal? So there's actually 3 questions in one. I hope you got all of them.
Okay, so yeah, he's right. This 5 minutes is just from an example that was the exercise by Rioja and Dobson with the VLBA at like mid-centimeter frequencies. So it's true that for lower frequencies that cycle would be different. So he's correct on that. Second question was,
what if we are observing with a dipole array where pointing the beam is stepwise and locating a calibrator, observing it and getting back to the target takes some time? How can we do astrometry with that?
Okay, so if you got an array with multiple beams, phased array beams, in principle, you are able to have all these beams simultaneously. So you won't need to swap between your target and your reference. So you will have already these beams pointing simultaneously to these two different directions. So it will help us tremendously. And the third question was?
Yes, this was related to if we have that set up, how do you do astrometry with that without using self-calibration? But I think you basically answered that. If you have the beams pointing to different calibrators while you're observing your target, you basically know exactly where you're pointing, and you should be able to maintain, to keep your astrometric precision.
Yes.
Yeah. Okay, the next question is from Gisela Ortiz. That was rather at the start of your talk. Are these advanced calibration techniques, specifically the calibration from geodetic-like blocks, already implemented in CASA?
I don't know. I think that's something that you include, the geodetic blocks, you include them in your, maybe some of the panelists know, but it's something that you include in the schedule. So you need some advice from people that knows how to do this, how to schedule these blocks. But it's just adding the blocks every, let's say, every hour in your observing schedule to correct for the tropospheric, in this case, the tropospheric effects, or the ice blocks for the ionosphere, that I guess that would be. So it's just the blocks on certain reference sources that you do in certain frequencies also. So you have to define maybe different observing frequencies for those blocks from your target program.
Yes, so maybe does any of the other panelists want to comment on CASA and geodesy at this point? Very quiet. I must admit I'm not entirely sure, but I do know that from the JIVE side, the development for CASA is focused on the astronomy applications. And I've heard from several angles there is more and more interest from the geodetic community to start using the tools, but there is still some work to be done there.
Yeah, also I can say that at least from mesoparallaxes, I know that most people that worked in the Bessel program, they used Mark Reed's, because you indeed you observe these, these geodetic blocks as Christina explained, but then of course you want to derive additional corrections in delay and delay rate for each antenna. You want to derive the delays per antenna and then apply that. So to find those numbers, I don't think there is a routine in CASA that does this calculation for you. So we had a script in Fortran written by Mark. And I don't know if somebody has a plan to code that into CASA. Hopefully, yes.
Well, that's definitely something to keep in mind, that there is this interest, and it's something to also advertise and talk to the NRO people about. Okay, I'll continue with the next question from Harro Verkouter. Did I understand correctly that a VLBI data product will be simulated to be sent off for correlation and processing? So I guess he's referring to the data challenges that you discussed.
Okay, we haven't defined them yet, but yeah, that could be one of the, although the simulation, well, the data challenge that we thought was after the VLBI correlator. So with the number one was using the visibility, so the product of the VLBI correlator. But it's true that the VLBI correlator will be able to handle these multiple beams telescopes. So it would be also very nice exercise to simulate these voltages.
Yeah, I had a follow-up question on that actually, because the simulations, the slide you showed, indicated that you're simulating the SKA VLBI data products, and there should then also be an additional simulation for the VLBI telescopes that are added to the SKA. Is that going to be part of the whole data challenge project, or do we have to add the simulations ourselves somehow?
So we haven't. We just brainstorm on how this VLBI data challenges could be, and we've just received interest from when we discussed about it in this workshop we had last year. So scientists were very interested on doing simulations and having these data challenges. So yeah, any idea you may have. So as you can see, it has not been advertised yet, this data challenge. But yeah, send me an email and we'll think about it.
Yes, it sounds very interesting. Okay. So that was Haro's question. Then at the top at the moment, there is a question from Victor Perez Diaz. Will those satellite constellations ruin VLBI and radio astronomy? And how can we live together?
Okay, so Starlink is already producing RFI in the regime from 10 to 14th gigahertz. So SKA is getting quite worried about it, because it would be the upper part of their band 5. And yeah, that could completely ruin that band. And in the future, they want to go to higher frequencies, around 20 gigahertz or so. And that's a very important band for radio astronomy. So it's it's quite worrying, because that's something that you cannot get rid. You cannot avoid. They are all the time. There are so many thousands of satellites that they would be on view, and with this so extended arrays, they would be on view all the time. So it's quite difficult to get rid of their signal. So that's quite worrying.
Yes, I know we had a launch presentation a few weeks ago from Walid Makour, who is the CRAF frequency manager and located at JIVE. And he mentioned that there are discussions ongoing at very high levels on how to manage this and make sure that at least for future events there will be less impact on astronomy. But this is definitely a big concern, and it's on the agenda at several locations. Okay, the next question, this is a nice one, from Sumit. Is the SKA VLBI going to be the extended EVN?
Yeah, you can see the other way around, that SKA VLBI is going to be the standard SKA. But not only the EVN, LVA is also very well positioned to participate and collaborate with the SKA, as I showed you in some of the UV plots, the UV coverage plots. So, and the East Asian VLBI network also is very well situated, and it's not only the array that is going to be in South Africa, is also low, SKA1 low, that is in Australia. So for that, is the Asian VLBI network would be very well situated, and the LBA as well. So yeah, I don't know what is the first, the chicken or the egg.
I think it's a bit of a trick question, and politically potentially dangerous to answer this, but yeah, it's nice to see actually that I think what was clear from your talk is that there is more and more efforts to do VLBI in a global organization, and people are starting to talk to each other from many different countries to make this a true global effort. And in that sense, I think VLBI is quite unique in the scientific world, that we do have that opportunity to join forces in non-political levels. Okay, there's one question left, also from Sumit, and this is a bit of a technical question, maybe also related to the previous discussions that we've had in the workshop. He's asking, I'm a little bit confused. Which one is more important while data processing, dynamic range or signal to noise ratio? Maybe it's silly to ask, because we always check signal to noise ratio improvement after each self-cal iteration. I don't think it is really silly to ask. I think it's a bit of an approach question. Do you want to answer this, Christina?
Well, I know the subtlety between the difference between both of them. So dynamic range is the peak. It takes into account the peak in your image. The signal to noise ratio is more with the like the mean, I would say, of the signal that you get on your source. Well, I'm not sure if I've explained it right, but there are some subtleties between both of them. And so, yeah, it's a very technical question for imagers, and I'm not an imager. So I would be very thankful if some of the panelists could answer.
Christiane, do you have an opinion on this?
Sorry, I have muted that here because I have very bad connection.
We can not really hear you very well, Christiane.
Yeah, I have very bad connection here. Can you hear me?
Yeah, this is better.
Okay, so for the same reason I have missed the question and now it's not anymore in the Q&A.
Sorry, I didn't.
Okay, I'll try to answer this in Mattermost as my connection is very unstable.
Yes, fair enough. Yeah, I think Christina also got the main point across. It's a matter of taste a little bit, but there's somewhat different approaches. Any of the other panelists have a strong opinion on this that they would like to share? Probably not. Sounds very quiet. Okay, then that was the last question in the Q&A. There was a remark from Amy Kimball that the image of the biker was really hilarious, and I totally agree with that. And that's the bit of an awkward issue when you're giving a talk to a screen. You don't see how people respond to your jokes, and it feels really, really silly. But I was glad to see that you tried to lighten things up a little bit with some fun stuff. So thanking Christina, thank you very, very much for this presentation.
Thank you.
So thanks to the other speakers of this week. It was a real pleasure to hear all the discussions and the presentations, and so far we've all learned a lot, I'm sure. So we're closing off the lecture part of this, and we'll be moving on to the pub quiz. So for people who are registered for the workshop, please stick around and join us for the quiz. Olga has already shared some information on the Mattermost channels, and she will take over from me in a few minutes to host you through the quiz questions. So Olga, would you want to start sharing your screen?
Okay.
Do we also still need to share the login information with people?
Yeah, we have it on Mattermost channel, and also it will be on the first slide.
Okay. So maybe we could put up the first slide so people can start.
This one is already with question.
Oh, right. Okay.
But yeah, probably.
So I can try to copy and paste that into the chat. So.
Oh yeah, please.
Okay, so it's the. Oh, these autocorrect things are awful. So we'll give people a minute or so. We'll start the quiz at 1:45. In the meantime, that gives me the opportunity to announce the fantastic prize that people can win. And I've got it here on my desk.
Yeah.
I have to keep it in front of me, so otherwise you can't see it. It's a mug, and it starts off at L bend. it goes all the way to S-band, C-band, X-band, and T-band. So these really nice mugs were generated by our PR officer, Gina Maffei, and have been shared with the JIVE people only. So for the quiz winner, you'll be one of the few people around the globe to be the owner of such a mug. So if that doesn't excite you, I don't know what does. A beer maybe, but... Okay, we're at a 1:45.
Yep.
Oh, there's a question how to log in. So maybe, Olga, you can talk people through that, or we keep the first slide open a bit longer for people to enter?
Yeah, you can just go to the, what's the name of website, like Slido? Slido, yeah, this one. And there you have a box where you can select the number of event.
Okay, so you open your browser essentially, and then in the address, you type sli.do.
Yep. But also on the first slide, I will have a QR code. So if you would like to use your phone, you can just scan it. So prepare your app to scan it.
And then, yes, if you're using the browser interface, then on the left-hand side of the page, you get this enter event code box, and you can join it. Okay, it worked. So we're good to go.
Okay, great. Here we have several questions from our tutors. So they are going to ask you all the kinds of questions, though that's not only about CASA and this workshop, while some questions are included on this topic. So please pay attention and I will read them for you. But you also will have this slide, so you can read this one. Okay, here we have a QR code. So yeah, we already have some people joining. Great. So probably we are ready to start. We'll have 30 seconds for each question, but maybe I think that with some we can skip them faster if you will ask faster. But yeah,
this is fine.
Yeah, this one is about what telescope array starred in the movie Contact. VLBI, ALMA, and VLA. And we are almost there to check this question. Okay, yeah, exactly. Most of the people answered right. That was VLA. The second question. Oh, also we'll check our leaderboard after each slide. How many horns has a narwhal? This one is a bit off topic, but still interesting question. I'll give you some time to answer, but probably this one is easy one. Okay, I suppose that about half of time is enough with this one, right? Yay. Yes, still some of people think that this one has no horns, but apparently one is here. So yeah, one is the right answer. And okay, Paul is the first one. Congrats. In the novel Lord of the Rings, how many rings of power were given to the race of men? 9, 11, 13, or 5? I suppose that most of you know the question. Oh, the answer. We're all fans. So, and yeah, we're almost there. Ready to see the answer? And oh, okay. 9. There were 9 rings.
And there is already a debate about the previous question that the narwhal didn't actually have a horn.
Okay.
Oh, yeah, sorry.
Yeah.
I don't know.
We can discuss it, yeah, later.
Over a beer.
Yeah. Okay, congrats to our leader. This one. What two motions do all planets have? Twist and shout, wiggle and wobble, orbit and spin, rock and roll. That will be really cool if they could do rock and roll. but probably that's something else. So let's check what we know about planetary science. Okay, and that's almost the time. Let's check. Yay, most of us know the answer. Like, yeah, of course, that's orbit and spin. And our leader. Which country has 3 capital cities? South Africa, China, the United Kingdom, and Somalia. This was what's completely new for me. I had no idea. But as far as I know, one of our tutors are from South Africa, right? So probably we'll have at least one right answer. Okay, and that's almost time. Right, yay, South Africa, right? Great. Our leader. What year was the first EVN observation performed? And bonus, at what frequency? 1980, 6 centimeters, 1975, 1 centimeter, and 1989, 18 centimeter. This one is a hard one. So think about carefully. Okay. And the first one. Yeah, this one, I suppose that will be the hardest question on this quiz. So, okay, great, but we still have a leader here. What's the real name of the Joker in the 2019 movie? Jack Napier? Sorry if I pronounce it wrong, have no idea. Frank Miller or Arthur Fleck? This is a pretty new movie, so I suppose most of us seen that one. Okay. And let's check who is that. Okay, Arthur Fleck. We have some movie fans here. And who is the leader? Okay, great. 7 out of 7. What's the most viewed YouTube video at the moment? Of course, while people have not yet discovered our workshop channel. Is it Gangnam Style, Baby Shark Dance, or Despacito? Okay, and this one updated just recently, so think carefully about this one. And let's check. Okay, right, that's Baby Shark Dance. And, oh, still, cool. Congrats, Stefano. Which country consumes the most chocolate per capita? Switzerland, the USA, or Brazil?
I would have thought Belgium.
Yeah, I should have put this one. Yeah.
So I'm out. I can't.
But still, we have nice options here. So I hope you know. And the right answer is, yay, that's Switzerland. Okay. Still, we have.
I should tell people we have Seek trackers on Google, so to get check what you're sneakily Googling all the questions.
Yeah, please don't do it. In 2019, the Event Horizon Telescope announced they had successfully made the first image of a black hole. This was not the black hole in our galaxy, but in the nearby galaxy M97. What's the NGC number of M97? Oh, 87. I won't read all these names, so I hope you can read them themselves. And let's check what is it. Also, hard question. I have no idea myself. Yay, this one. The second option is the right one. But cool, Stefano still knows. What's the Roman numeral for 500? D, L, C, or X? This one is a hard one, right? We know more about our closet size or something like that, but with hundreds, that's hard. But I suppose that some of our participants know. Yay, right, that's D. Okay. What is the hypertelescope? A solar system-wide interferometer, an interferometer with elements that are only satellites, a spherical interferometer. Okay, I had no idea.
That is a really hard one.
Yeah. So. And okay, looks like nobody knows. So yeah. Okay, why we don't? From which Dutch city did we start our collective walk yesterday? Was it Amsterdam, Assen, Maastricht, or Utrecht? You should have participated in our collective walk on World Walking. I hope you invested some steps there, so you probably know which city. And right, that was Maastricht. Okay, I'm happy to see that some of your things that's Assen, because nobody knows where it's Assen. And oh, we have a new leader here. Nice. What's the name of Don Quixote horse? I also have no idea how to pronounce all of that, so please just read it. Hope you're more educated than me.
Rocinante, ruspante,
oh,
rampante.
Thank you. Okay, I will need you for one more question at the end of this presentation.
Okay.
And let's check the right answer. Yay!
Rampante would be a good name for my cat.
And if I remember correctly, we again have a new leader here. Congrats. What living creature might be immortal? Okay, I know this one is offensive a bit, but maybe that's...
That's fantastic.
Maybe that's Queen Elizabeth, immortal jellyfish, or Galapagos saucer.
The answer is in the answers.
Yeah, maybe there are some spoilers here.
Yeah.
I don't know.
But just for the fun of it, I would have chosen Queen Elizabeth.
Yep. And okay, we have some people who think so. Okay, congrats to our leader, and let's go further. VLBI astronomers have a reputation for enjoying a good beer. Some are even known to brew their own. In recent years, there is an increase in small breweries making quite particular type of beer. What's the chemical formula for alcohol? Again, I think that's better to just leave it for you to read. And let's check how many chemistry experts are there. And yay, a lot of them. Great. Congrats. This one is an important one for our conference at least. When Zoom Video Communications Inc., which is Zoom, was founded? In 2011, 2019, or 2014? Okay, let's check. I actually thought that this company is pretty young, but let's check what's the year. And okay. Nice to know. Congrats to our leader. Which of the following is not a capital city? Sydney, Cairo, Beijing, or Moscow? I'm pretty sure about Moscow, but what about others? Let's check.
It's not a capital city for sure, but that's not on the list.
that's almost time, so think carefully. And right, that's Sydney. Who did the Dutch men's team lose to in the final of the 2010 Football World Cup? Spain, Germany, or Argentina?
Yeah, rub it in.
I know that one.
Yeah? Oh, cool. I thought that's only for football fans because I had no idea.
Even I know that one, and I hardly ever watch football. It was just so painful.
Oh, okay. Now I see. And yeah, a lot of people have this pain in their heart. So yeah. What does the letter C in CASA stands for? Is it cool, casual, common, or calibration? We all suppose that that's cool, but let's check. Okay, I hope you all listened carefully to my talk on Monday, and you know this, yeah, that's common, right? But thanks to all who voted for cool. I agree with you. So, unlike the original Star Trek series, which is a classic example of the tokenism and principle of Smurfette, hope you all know what that. The newest sequel is quite diverse and features a black woman in the lead role. What's the name of the main character? Again, I'm not sure that I can pronounce all of that right, but I hope that you at least checked this TV show and you know the answer. Let's check what's that. And that, okay, I still will not read it, but I'm happy that many, at least a lot of you read it. I mean, checked this show. And yeah, we have a leader here. What's the chemical formula of ammonia? Again, some chemical formulas. I hope that at least some of you know that. Actually, spectral line people know.
Yeah, people should know this.
Yeah.
At least they should know what it's not.
Yeah, right. We can go this way. And let's check. Right, most of us know. One more hard question. What's nomophobia? The fear of being alone, the fear of not having a working mobile phone, the fear of precisely following the law. Okay, I suppose that now all of us kind of have this fear, but don't think that's a spoiler here. Okay, right, that's a fear of not having a working mobile phone. Something that we really need now. And we have a new leader. Congratulations. If you light a candle in space, what shape would the flame have? None at all, a sphere, or a drop? Think carefully about it.
This is a trick question, actually.
Yeah, we got this one from one of our tutors, so we can discuss it later. And the right answer, according to our tutor, that's a sphere. So we can discuss it later, okay?
The assumption that there is sufficient oxygen.
Yeah, exactly. But maybe like on board of spacecraft or something, yeah. And we have the same leader now. What's the banana recipe at the end of the chapter 3 of Abe's cookbook? Banana bread, banana mandarin cheese pie, or banana daiquiri?
Yeah, that reminds me we should start to collect recipes for the CASA tutorials.
Yeah, that's a nice idea. So, what's that with apes so far? Okay. but careful readers knows that banana mandarin cheese pie. And we have a new leader. What's the color of the peel that Neo swallows in the matrix? The green peel, to learn how to add more vegetables to his diet. The blue peel to go back to the matrix and its reality. The red peel to learn the truth, namely what there is beyond the matrix. Okay, and which one is this? I would like to have the green one. And the right answer is, yay, most of us know. Great, right, the red peel. Congrats to our leader. How many soccer fields fit in the total collecting area of the new fast radio telescope? This one is hard, I suppose.
I like the decimal values.
So let's check it. And okay, not suspicious at all, right? But the second option is the right one. And we are almost there. How many steps do you think we walked together yesterday? Okay, I checked the website right before this quiz. So maybe now there is a different number, but at least an average that should be the right value here. So think carefully. And how far we go? Right, exactly. The second option's here too.
Did we reach Rotterdam yet?
I don't think so, at least not before this quiz. And okay, congrats to our leader. It looks like you are here to stay. Because we have one last question. We started with the Spanish word casa at the beginning. And how would one say goodbye in Spanish? Cristina, can you help me with this one?
Adiós, salir, hola, and that's French, au revoir.
Okay, so that leaves 3 answers.
But maybe I'm that bad in Spanish, so I put something in French. And yeah, right, that's adios. And congratulations to our leader. Great, 22 out of 29.
Yay. You get
Congratulations.
Yeah.
the T-band mug, yay! Now we have to party.
Cool, yeah, that's a kind of cup, you know, you win a cup, so.
Yep. We'll make sure that the mug gets to you. We'll dig out your credentials from the registration list. And then it will find its way.
Cool.
Awesome. Cool. I really enjoyed this.
Thank you everyone for participation.
Yeah, I hadn't seen the quiz before myself, but it's...
yeah, that's a surprise.
Yeah. So, but since I submitted questions, I did not participate.
Okay, thank you everyone. I suppose I can close this one.
Yeah, you can close that one, and then there is only a short few things for me to say as a wrap up of the workshop. So congratulations are coming in on the chat. So I'll share my screen. Where is my screen now? Okay, here. And this one down here. No, that's not working, sorry. Keep it here. Okay, you can see the wrap-up slide, right? Because my screen is now starting to mess up itself.
We have a like white line.
Oh, it's paused, sorry. Start sharing. No, there's something going wrong on this, and I'll restart the sharing. Then we should be going from there. So now you see the PowerPoint, right?
Yep.
Okay, excellent. So wrapping up, I had no idea in what state of mind I would be at the end of this workshop, but I still find myself mostly alive. My sink is stacked with the dishes of 4 days, but I'll handle that over the weekend. I was really excited to see all the engagement. It is always a bit strange to organize these things virtually, and you don't really know what to expect. It's the first time we've done this. And I was really impressed with the work that people have done and the engagement that we saw on Mattermost and the discussions that we had also between the tutors. And in spite of the disappointment in day one, when we couldn't get the breakout rooms to really work as we had expected, everything went remarkably smooth. So this is good news for me and for everybody else, because we will be continuing this kind of workshops, hopefully also in real life in the future. And we'll definitely do our best to keep an online component for people with who have more problems getting to Europe or for whatever other reason cannot attend in person. I think, and overall, this was quite successful in the way that it's been able to do this. So, as a wrap up, what else is there to say? Social events. We had a winner, yay! And you will get this really cool mug. The walk distance, but this was probably just before Olga checked, because I got up 175,000 steps, which is 131 kilometers. But actually there was already a few 10,000s more. Still, it's not a very long baseline from VLBI point of view, right? It's 100 to 200 kilometers, barely exceeding the LOFAR baseline. So we should continue. We can definitely continue to walk. We'll keep open the World Walking Platform and the CASA-VLBI walk, and do continue to join us there and add steps, and maybe at some point we can even make it to Assen.
Yeah, not even the shortest baseline in the EVN, I'm afraid, unless you count.
No. So the photo uploads are still open. You can continue to upload photos at least until the weekend, and we'll start to make the mosaic and share this with you digitally. And I hope there will be sufficient photos. The more we have, the better it looks. So with this, we got some questions from people after the last discussion, data processing session, of what can you do if you're really a beginner, or if you just want to learn more about radio interferometry. So here I have listed a few of the events that I know of, which are not just for beginners, actually. I still find them extremely useful myself. And I must say that for the first two, for the ARIS and the ERAC, the funding used to go through the RadioNet project, which is a European funding project. And I'm not 100% sure how this will shape up in the future, but I do know that a follow-up project from RadioNet, which is called Pilot, has just been granted the requested funding. And I do think I remember there was opportunities there for funding more of these kind of schools in Europe. For sure, there is funding in that project for funding more CASA workshops. So that will definitely continue. The LOFAR people also have their own school every other year, usually. Just like the NRAO summer school is also every other year. And I've managed to add dates to everything, but of course, these are now highly dependent on the current corona situation globally. So NRAO was a digital school this year, and in 2 years from now, they should be hopefully again in person. So as far as the existing materials go, we've got very useful information over the week. Most of it has been collated on the wiki page, and we will spend the next couple of weeks to move everything that is useful and that we want to keep for future reference to the website. So we do a little bit of filtering. For the Mattermost channels, that means we'll start to do a little bit of making a sort of frequently asked questions document. So some questions came up several times. Some questions required quite a lot of discussion. And we'll filter those out as well. And everything that is useful for you will be added also to the website. So after about a month, I hope we're done with this. And then the wiki page and the Mattermost channels will close. But you will get sufficient notification beforehand so that you also have the opportunity to download materials that you would think are still useful for you. Of course, all the YouTube recordings will remain online. You are still having access to those, and you're welcome to to keep sharing those. There's been quite some engagement on YouTube, and I've heard that especially the subtitling and the translations from YouTube are really excellent. And Jack, I think it was Jack who mentioned that Zoom will start doing similar things soon, but not for this workshop. So finally, if you want to stay in touch with us, and especially for those of you who are working on EVN data and running into problems, there is the generic user support email at JIVE for any EVN related questions. And of course, there is the EVN seminar series. If you're interested to follow what's been done with VLBI data and EVN data in particular, you're welcome to join us. It is about every other month, right, Benito?
Yeah, roughly every 7 weeks.
Okay. And the times and days are scattered throughout the week, so it's not always on the same day and it's not always on the same time. This depends on the speaker, of course, but we're also staggering this to make sure that we can address different regions around the world. So not just thanks to our sponsors, but also thanks to you, to all the participants, and also to the tutors for being here and helping out. I really enjoyed this, and I'm really happy with how things have gone. I hope you share this experience, and please let us know if there's anything that you think we can improve, in particular for the data processing sessions. We had the 1 hour of silence, and I thought it would be quite off-putting to some people that you're not really hearing anything, but still having the time allocated in the program to really work on this data, for me was actually quite helpful to get some stuff done, rather than being tempted and go read email or do other meetings, things like that. So that's it for me. We are at the 6:15 local time. I think I am going to get myself a beer and put my feet up, wash my dishes. Anybody for some famous last words? Yeah, no, my glass is empty. Aro Vakauter is raising his hand. Oh dear. Let me see if I can do something about that. Oh no, I'm still sharing my screen and all my buttons have disappeared. People raising their hands, where are they? There. Amy, you want to say something? You go ahead.
Thanks, Ilse. Normally in a live conference, someone would lead a round of applause for you and all the other organizers, and pretty much everyone is muted, but I want to do that. So if everyone can applaud with me. This is fantastic. Thank you so much.
Yeah, that's the down point of the virtual stuff, right? That's what I said to Christina. You don't get that feedback, and I really missed that during this week. Also, the opportunity to just chat with people and have a cup of coffee with everybody. And so I really hope that for the next one, we can also have in-person discussions and chats. Thanks. More applause coming in through the chat. Awesome. Thank you, everybody. I'm going to call it a day and hope to see you next time in person. Bye.
Goodbye, everyone. Thank you, Ilse.
Bye.
Bye-bye.